Hey there, today or right now, what I'm going to do is I'm going to take some notes on the future value of investments. So I've got my I've got my PDF open on my computer, and this is the best way I've got to be able to, kind of transfer my own notes. So we are talking about the future value of investments. And these are my notes. So let's get started. My learning target for today will be I can calculate the future value of a periodic deposit investment. Lots of words there, so let's get started. Suppose you open a high yield savings account that calculates interest by a method of compound interest. So what we've been talking about is we've got compound interest, multiplying our money in our bank account. Many times people will add to their savings account on a regular basis. It may even be a good idea to set up periodic investments. So that's a good keyword, periodic investments, which through your online banking system. So what periodic investments means is this is going to be a regularly scheduled payment. So a lot of times people will have a regular scheduled payment that drops right into their savings account. Because remember, even the smallest deposit could multiply over the years or decades. So let's go ahead and think about my scenario here. Let me introduce to you this formula. We've got B equals P times, check that out, you do need that double parentheses, 1 plus R divided by N, parentheses, raised to the power of N times T, minus 1, close the parentheses. So notice these parentheses go together, and then these parentheses go together. And all of this is divided by N, or R divided by N. This is a monstrous formula. This is not going to be achieved by using your cell phone calculator. We will use Desmos.com to help us out with this one. So what do all of these letters mean? Well, B is going to be my end balance. P is different. Usually we've been talking about P as our principal, but now what we're saying is every single month we're going to put the same amount of money into our account that's calculating, that's compounding or getting interest paid out with compound interest. So P will be our periodic deposit amount. You could think of it, it's still going to be like the money value. So periodic deposit amount. The next letter is going to be the same. This is R, will be our rate as a decimal. So remember, this is the same letter that, like, if you have a percent, so 1.2%, you're going to convert that into a decimal. N, we've been working with N. N will be the number of times interest is compounded in a year. Interest is compounded per year. So remember, if it's daily, N will equal 365. Monthly, N will equal 12. Quarterly, N will equal 4. Semi-annually, 2. Annually, 1. And last but not least, T is going to be your time in years. So I've been talking about this bank account that I just opened last Friday as I was preparing our lesson. And I chose to open a bank account with PNC. It's a bank that I already use for my checking account, and now I'm interested in taking advantage of their high yield savings account. And so what I've done is I've gone into my online banking and I've actually found the setting that says automatically transfer $50 every single month. So I get paid the very last day of the month, and so the very first day of the month, what my bank will do is automatically take $50 out of my paycheck and put it into this savings account. So in order to calculate, well, how much money do I want to have in 10 years, which is a true story. I literally named that bank account Don't Touch Until 2030. I'm trying to figure out, well, how much money will I have in there? So B is what I'm trying to find. I am getting all of these numbers from problem number 1. Suppose a person, meaning me, sets up their bank with $50 deposit per month on an account that pays 0.9% interest compounded monthly. How much money will be in the account after 10 years? So B will equal, my P value is periodic deposit amount. So I'm depositing $50 every single month. That 1 will always be there. Plus, my rate in this problem is 0.9%. So remember, in order to find rate, right now I have 0.9%. In order to determine, this is my R value, of course, what it will be in a decimal, I will either move this over once, twice, it'll be 0.9, or what you could do is take that number, divide it by 100, and you will still get the same thing. So 0.009 divided by, in this problem, it's telling me interest compounded monthly. So compounded monthly is going to be 12 because there's 12 months in a year. So maybe I should be writing out these values right here just so you guys could see. So my P is $50 a month. My R is 0.009. My N is 12 because of compound monthly. And then my last letter I gotta find is T. Well, I'm not touching this bank account for 10 whole years, so T will be 10. So when I come back here, I am doing to the N times T. So 12 times 10. I've still got this minus 1 right here. Close that parenthesis, so just like this. Divide everything by R divided by N. 0.009 divided by 12. And finally, we are going to use desmos.com/scientific as your calculator. The best thing you can do right now is pause this video, put this whole equation into desmos.com and see what you end up getting. This is going to be very valuable because then that will show that you are able to, properly put these values in your calculator. So here we go. I got 50, left parenthesis, 1 plus that division sign, 0.009, down arrow, 12, raised to the power of, you do that by holding Shift 6, 12 times 10 is 120, minus 1, close that parenthesis. Whoa! I hit enter too soon, and so what I'll do is I will do copy paste. And then this is by 0.009 divided by 12. And my final answer is B will equal $6,275.82. Therefore, if I put $50 away every single month after 10 years, this account is actually going to have $6,275.82. I did the math, 6 times 12, or 50 times 12 times 10 was just 6,000. So in reality, I made $275.82 in interest. So this is going to be, just to recap, what periodic investments are going to be regularly scheduled payments, aka Putting money aside on a regular basis. There we go.